Welcome everyone. Today we're going to start drawing more complex shapes than just rectangles using our shape batcher. And so let's add some functionality to do that. But the first thing I want to do is actually change the line drawing routine to determine if we're using the camera to draw the line or not. The reason I want to do this, I want to be able to determine if we're drawing in camera space or screen space. If we're drawing in screen space, everything's just going to draw exactly the same. The line will draw and look exactly the same as it ever did. But if we're drawing in camera space, I want the thickness of the line to remain visibly the same regardless of the zoom level. And I can illustrate what that looks like. Let's say we've drawn a line to the screen that looks something like this. This is a zoom level of 2. If we were to now zoom into level 4, the line is going to look something like this. It will be, and that may not look exactly accurate, but it'll be twice as thick as the previous line. But what I want to happen is when we're at a zoom level of 4, I want the line to look like the same thickness. As we're zooming in, at a zoom level 4, we're going to see twice as much of the line, but the thickness should remain the same. In order to make that happen, we need to save a reference to the camera class inside the shape batcher. Now when we start batching, we already bring in a reference to the begin batching function, and I just need to save that reference so I can use it later. Let's make a field here inside the shape batching class. This is going to be the camera. When we create the class, the shape batching class, this camera reference will be null. And then inside begin, I'm simply going to save a reference to the camera class, or to the camera object that we brought in here. This value could very well be null. If it is null, that just means we're drawing in screen space and we don't need to do anything else. If it's not null, then we're drawing in camera space. Now we need to start making adjustments. And the adjustment's going to happen down here in the line drawing routine. After we've got the final thickness value for our line, we're then going to adjust it by a ratio. That is the ratio of the current camera Z position to the base Z position. We want the line to look like the same thickness as if we were sitting at the base Z, regardless of what the actual Z is. And first we're going to check to see if the camera reference is null. So if it's not null, then we want to adjust the thickness of the line, which means if the camera is not null, it means we're drawing in camera space. So we need to adjust the thickness of the line. We're just going to tell the thickness that we want to multiply it by the camera Z position divided by the camera base Z position. And so let's go ahead and run this code and make sure it's working like we're anticipating. And so this is where we left off last time, and you can see the thickness of the line. As we zoom in, we should get a better view of the line, but the line thickness itself should stay the same. And that looks right. The thickness of the line is not actually changing. I'm actually going to take out the sprite drawing for now, so we can get a better view of it. Let's run that again. Okay, so as we zoom in, the actual thickness of the line stays the same. We're seeing the line. The line's taking up more of our view. The thickness remains the same as if we were at the base Z. Okay, so now that we have that, we can start drawing more complex shapes. Let's go ahead back to our shape drawing batcher. These are all going to be outline shapes that we're drawing right now. So the first one is going to be a draw rectangle. Just like our previous draw rectangle, our previous one was draw rectangle fill. We're just going to do plain draw rectangle. It's going to draw a rectangle outline using our line function. And we're just going to have the same parameters here for this one, so we can just copy this directly. And we come down here, we say we'll put that in. All we need to do now is calculate the boundaries of this rectangle. So the first one is going to be the left. That's just going to be the x. The right is going to be the x plus the width. The bottom is going to be the y, and the top is going to be the y plus the height. Now we can just start drawing lines. We're basically just going to draw the lines of the rectangle. So we'll have the top line, the right line, the bottom line, and the left line. So if we're starting here, this is going to be, the x is going to be the left, and then the y is going to be the top. And then we're just going to go around and draw each one of these just like that. Go back to the code. Okay, so now we're just going to use these boundaries to draw the lines. So we'll draw a line. We're going to start at the left and the top and go over to the right and the top. Pass through the thickness and the color, and there's the first line. And actually I did not provide a thickness up here, so I need to provide that. Let's put a thickness. Now we can copy this and just paste it 3 times. And so now that we're on the right top, we need to start at the right top and then go to the right bottom. From the right bottom, change these, so the right bottom, we're going to go to the left bottom. And then from the left bottom, we're going to go back up to the left top. So we need to put the left bottom, and then we'll go to the left top. So you can see now that we have this line drawing routine, actually drawing the rectangle is very simple. Let's go ahead back to our game class. Let's try this out. I'm going to remove all of this other drawing code we had. I'm going to change the background color to black. Then I'm just simply going to draw the rectangle we just created. And we want to draw a rectangle. Let's start at, just say, a -64 on the x. The y will be at 0. The width is going to be 64, and the height will be 64. The thickness will be 1, and the color, let's just use white, and let's see what happens. Okay, there's our rectangle. And you can see the bottom left here is at 0.64. It's 64 by 64 wide and high, and if we zoom in, you can also see that the actual width of the line, as it appears to us, does not change at all. And that's the effect I was looking for. There's the rectangle drawing routine. Next one is going to be the circle drawing routine. So let's go back into our shapes. We're going to draw a circle. We want to pass in an x and a y, and that's going to be the center of the circle. We want a radius. We also want to pass in a thickness and a color. And actually, now that I look at this, there's actually one more thing we want, and that's going to be the number of points that define the circle. Let's go ahead and draw what that looks like. So as we're drawing a circle, we're actually drawing an estimate of a circle. We're not actually drawing a real perfect circle. We have to do that because we're actually just connecting lines together that make a shape that looks like a circle. If I draw kind of what that looks like, we're going to have points, a certain number of points that go around like this, and we can connect those with lines. And if we have 6 points here, so if our circle is made up of 6 points, it's actually going to look something like this, because we're just going to connect points of the circle with lines. Let's go back to our code. I do want to define a minimum and maximum for the number of points that we allow. So just in here, I'm going to say min points is going to be 3. If they do define the min points as 3, it'll actually look like a triangle, right? It'll just draw a triangle with 3 points. The max points is going to be 256. We need to now determine how to space the points out so we get a circular shape. Let's draw a point here. This is going to be the center. The first point is always going to be here. But now we need to figure out, how do I get to this point? This point is simply the angle between here and here. If I can figure out what this angle is, I can figure out what this next point is going to be. Well, the circle is just going to be actually divided up. We'll draw the lines here to see how it's divided up. So if we have 6 points, we actually have 6 different areas, or 6 different angles that define how far we need to go to get to the next point. All we have to do is divide the whole circle, which is 360 degrees, by how many points we have, and that'll tell us basically the delta angle, that how much of an angle do we need to change to get to the next point. So we can do that by calculating a delta angle. Delta angle will simply be the 360 degrees, which is 2 pi, divided by the number of points that we want. We also want to save the actual angle in a variable as well. And the actual angle will be where we currently are. So when we start, we're at 0, which is this one here. And then when we add the delta angle to the angle, then we'll move up to this one. Then when we add the delta angle again, we're going to move over to this one, and then we're going to add delta angle to the angle again and move over to this one, and so forth until we've gone to visited every point on the circle. Okay, so now we have the delta angle that tells us how much we need to advance the angle every time to get to the next point, so they're evenly distributed in a circle. Now, one thing I forgot to do here is, now that we have the minimum and maximum points, let's go ahead and clamp the points by the min points and the max points. Alright, so now all that's left to do is we need to loop through the number of points. So while I is less than the number of points, let's go to the next point. We're now going to figure out the endpoints of each line. So the first one will be here, and the next one will be here. We can do that in our code. The first x is going to be the sine of the angle, and the first y is going to be the cosine of the angle. Then we need to advance the angle by the delta angle, and then we need to find the next x and y, which will be bx, will be the same thing. It'll be the sine of the angle, and then by will be the cosine of the angle. And then once we have those values, we can simply pass them on to the line drawing routine. So we'll pass in AX and AY, and then BX, BY, we pass in the thickness and the color. So that's pretty much it. The only problem now is that these points that are defined by AX and AY are actually centered at the origin, and they have a magnitude or a radius of 1. And so instead of being at the origin, we want to be centered at this X and Y position, and we want it to have this radius. In order to get that radius, we just multiply everything by the radius. So multiply all these values by the radius. And now we just need to add the X and the Y to move them to where they need to be centered. Let's go ahead and test out our circle drawing. Alright, so we have our rectangle drawing. I'm going to comment that out right now, and let's draw a circle. Okay, the center, we're going to put the X at 0, but then I'm going to move it up on the Y just a little bit. We'll just say 32. The radius, let's make it, we can just pick a radius. We'll just say the radius is 32 as well. The number of points, I'm going to make this fairly low. Let's give it 12 points. The thickness just going to be 1 for now, and we're going to make the color white. Okay, and there's our circle. That looks right. And you can see at this point we can see all of the lines. We don't have enough lines to make it look like a smooth circle. And as we zoom in, it gets even worse, right? We can now definitely see all of the lines. But that's exactly what we wanted. And in fact, if I were to change this value from 12 points to 3 points, it should just be a triangle at this point. There we go. And there's the triangle. That's the best estimate for a circle that we could come up with 3 points. Now, instead of 12, let's increase this to something like 48. We'll give it a lot of points. And so now we should see a nice smooth circle, and that looks really good. And even if I zoom in here, it still keeps like a really smooth look to it. Even though it's defined by points, there's enough points in there that it gives a nice smooth look. Even zooming in here really close, even now it still looks smooth. We can just barely start to see the actual line segments in there. But it still looks really good even at that magnification. Alright, so that's the circle drawing. Let's go ahead now and do the polygon drawing. And the polygon is going to be relatively simple. We're just going to have an array of vector 2's I'm going to call vertices. We're going to have a thickness and a color. This function is simply just going to loop through every vertex and draw lines between every vertex until it gets back to the beginning. All we have to do is loop through every point in the vertex array. We're going to get 2 vertices. First, we're going to get the one at I, and then we're going to get the next one, which is I plus 1. And now that would work for the most part until we get to the end of the array, and then when we say I plus 1, it's going to go outside the array bounds. And so what we want to do is once we get to I plus 1 at the end, we want it to loop back to the beginning and grab the first vertex. The way we do that is we simply mod that value by the length of the vertices array. That'll make sure we don't go outside the bounds, and then when we do get to the end, it'll start wrapping back to the beginning. And then all we have to do here is we want to draw a line from A to B with a certain thickness and a color. Okay, so that's it for the polygon. Really nice and simple. Let's make some random polygon points so we can test this out. We are going to make a vector array, and that's going to be called vertices. Let's make some random values, so I'm going to make a new random. Tell it we want the vertex count to be. We'll just say 5 for now. Create the vertex array, and let's just loop through every one of these until we've populated all the vertices. Okay, so we're going to calculate a random x, a random y, and then we're going to send those to the vertex array. For the random value, we're going to get a random integer. We're going to mod that by the width of the screen, and then we're going to subtract half of the width. And then the same thing for y, except this will be the height, screen height, and the screen width divided by 2. And that'll just pick some random points that are, I believe this is what it'll do, is pick some random points that are centered about the origin, but only go halfway to the edge of the screen. Down here we can test this out by actually drawing. Let's remove the circle code. Let's draw a polygon. We'll pass in the vertices. The thickness will be 1, and the color will be white. Okay, so let's see what happens when we do this. There we go. There's our random, in this case, complex polygon as we have lines crossing here. We should be able to zoom in, and the lines maintain the same thickness no matter what zoom level we have. Okay, it looks good. Let's try it one more time. Every time I restart, it should give me a whole new set of vertices. There we are. Now there's a simple concave polygon, and that looks good.